So here I'm giving the vertices and the foci. I want to find the standard form. My vertices are at 0, 2, and 0, -2. My foci are at here. So that tells me that A equals, first of all, I can first write my center, right? My center is at 0, 0. My vertices are 2 units away from the center, so A is 2 and C is equal to 4. Because the foci are 4 units away from the center. And so this means that B will equal, so here I just need to use the formula C squared equals A squared plus B squared. So if I do that, I'll find that B equals 2 root 3 or root 12. And so this is a vertical parabola, right? Sorry, vertical hyperbola. And so that means I need to have the y squared first. So it'll be y squared over a squared, sorry, minus x squared over b squared equals 1. So remember that the a always comes first, and then if it's vertical, then the y comes first, and they always equal 1. Question B. It's the same thing, except now it's horizontal. So the vertices are here at 4, 0 and -4, 0. My foci are there. So center is still 0, 0, but now a equals 4 and c equals 6. So that tells me b is going to equal um 2 root 5. So my formula will be, it's horizontal now, right? So x comes first. X squared over a squared minus y squared over b squared. Next, question C. So let me think about my vertices. I'm at 4, 1 and 4, 9, 4, 0 and 4, 10. So that means I have a vertical hyperbola, right? So my center is at 4, 5. It's right in between the vertices. So that tells me that A equals 4, because 4, 9 is 4 units away from 4, 5, and C will equal 5. And if I use the formula, B squared equals C squared minus A squared, then that's going to tell me that B equals 3. All right? Okay, so is this a vertical hyperbola? It is. That means y comes first. So y minus k squared over a squared minus x minus h squared over b squared. D, my vertices are at -1, 1 and 3, 1. The foci are at -2, 1 and 4, 1. So this is a horizontal hyperbola, right? So the center is going to be at 1, 1. and a equals 2, and c equals 3. So that means b equals root 5. 9 minus 4 is 5. Right? And so this is a horizontal hyperbola. So x comes first. X minus 1 squared over a squared. Y minus 1 squared over b squared equals 1. E. Here I'm given vertices and asymptotes now. So my vertices are at 1, 0, and -1, 0. So it's a horizontal hyperbola, right? And I'm also given asymptotes. They're pretty steep, right? Okay. So based on where the vertices are, I know the center is at 0, 0. I also know that a is equal to 1. And I also know that the asymptotes are y equals plus or minus 5x. And because this is a horizontal hyperbola, this should correspond to plus or minus, or the slope. The slope, plus or minus 5, should correspond to plus or minus b over a. And so that's just going to tell me that b over a equals 5. Okay? And if a equals 1, that means b equals 5. And so now I can write my hyperbola. It's horizontal, so x comes first. X squared over a squared minus y squared over b squared equals 1. F, now I'm given foci and asymptotes. So the foci are at 0, 8, and 0, -1, and the asymptotes are positive 4x, negative 4x. All right, so once again, the center is at 0, 0, but now I'm given C, right? I'm given the foci, so I know that, let me not write two C's, that's very confusing. C is equal to 8 because the foci are 8 units away from the center, but I'm given the asymptotes. This is a little tricky, isn't it? So the asymptotes have slope plus or minus 4. So that means that a over b equals 4, correct? That's because this is a vertical hyperbola, so the slopes of the asymptotes are going to be plus or minus a over b. So I know that a equals 4b. Now I actually have to do something more tricky, which is actually solve for a and b given what c is. So I know that a squared plus b squared equals c squared, right? Which is 64. So I'm actually going to have to make this substitution. A equals 4b. So that means 4b squared plus b squared equals 64. And that means b squared actually means that 16 plus 1, which is 17b squared, equals 64. So actually b will equal square root of 64 over 17. I'm not going to simplify that because I'm going to plug it into something else later anyways. B is equal to that, and A will equal 4 times that. So that allows me to now plug it into the formula. It's vertical hyperbola, so y squared comes first. Y squared over a squared which is 16 times 64 over 17 minus x squared over 64 over 17 equals 1. And I should simplify that a little bit just for good measure. 17y squared over 16 times 64, which is that 1024? What is 16 times 64? 2 to the 4 plus 2 times 2 to the 6. Yeah, 1024. Maybe this problem's a little too hard, isn't it? Okay, on to G. Here I have vertices at 3, 0 and 3, 6. I have asymptotes that need to pass through the center with slope -1 and +1. So that'll be like that. It's going to go through the origin. Okay. So where's my center? It's at 3, 3. And I know that A equals 3 because the vertices are 3 units away. I also know that this is a vertical hyperbola, so the asymptote slopes will be A over B, and that should equal 1 because the asymptotes have slope plus or minus 1. So that just means B equals 3. And now I can plug it into the formula. Here I have a vertical hyperbola, so y comes first. Y minus 3 squared over A squared for B squared. Okay, next H. Now my vertices are at -4, 1 and 0, 1. My asymptotes will pass through the center there with slope 1 and -1. So I have a horizontal hyperbola here, right? The center is -2, 1, and A equals 2. It's horizontal, right? So the slopes are going to be B over A. That should equal 1 because the slopes are plus or minus 1. So B also equals 2. Switched it. This is a horizontal hyperbola, so X comes first, right? Uh-oh, these look kind of tricky. Okay, so my foci are at -1, -1, and 9, -1. My asymptotes have slope 3/4 and -3/4. So this is a horizontal hyperbola. And the center is going to be at 4, -1, because the average of -1 and 9 is 4. I'm given the foci, so I know that C is 5. C is 5, and I also know that it's a horizontal hyperbola, which tells me that the slopes are going to be B over A. And this should equal 3/4. Now, if you're clever, you could immediately tell that B is 3 and A is 4, because A squared plus B squared has to be 25. But if you're not clever, that's fine too. You can solve it explicitly. This is just going to tell you that B equals 3/4 times A. We know that A squared plus B squared equals 25. So that means A squared plus 9 over 16 A squared equals 25. And then you can solve this. You would find that A squared equals 16. So A equals 4, B equals 3. All right, the center is at 4, -1. It's horizontal. So I'll have x minus 4 squared over A squared minus y plus 1 squared over B squared. J doesn't look very pleasant, does it? So my foci are at 9 comma plus or minus 2 root 10. What in the world? My gosh. So that's somewhere here, right? These are my foci. And my asymptotes pass through the center, which is there, with slope of 3 and -3. I don't know who assigned this ridiculous problem. Um, okay, so my center is at 9 comma 0, and I'm given C equals 2 root 10, because that's how far the foci are from the center. Now this is a vertical hyperbola, so that means A over B are going to be the slopes of the asymptotes, and that slope is 3. Okay, so that means that A equals 3B. Now I also know that A squared plus B squared equals C squared, which is 40. And so that means that A squared, which is 9B squared, plus B squared equals 40. You solve that, you should get B squared equals 4. So B equals 2 and A equals 6. Now this is vertical, so Y comes first. And I'll have Y minus 0 squared over A squared minus X minus 9 squared over B squared. Okay, let's do question 2 now. X squared over 9 minus Y squared over 16 equals 1. So this tells me that the center is 0, 0. The A is 3. A is 3. B is 4, which means that C equals 5, because C squared is A squared plus B squared. Okay, so now I can probably figure everything out now. Here's my center, and my vertices are going to be from the center going right and left A. this is a horizontal hyperbola, right? So the vertices will be right and left. Um, so that's just going to be plus or minus 3 comma 0. Then the foci, I'm going to have to go C, right and left. So that will be plus or minus 5 comma 0. The asymptotes are going to be y equals plus or minus, this is horizontal, so it should be b over a, so 4/3 x. I graph all that. Be a little steeper than that, right? Maybe even more so. My vertices will be at, well, it doesn't need to be that accurate, so that's fine. Okay, question B. All right, so remember, in order for it to be a hyperbola equation, the right side has to be 1. So I need to divide by 2 first. Okay. So my center is 0, 0. Um, A equals 1, B equals 2, so that means C equals root 5. Now this is a vertical hyperbola, so the vertices are going to be up and down of the center. So it's going to be 0 plus or minus 1. And the foci are going to be 0 plus or minus 5, plus or minus root 5. And the asymptotes are going to be A over B now. So I could graph it like this. It's vertical. Oh, this is annoying. 9y plus 6 squared minus 4x minus 2 squared equals 1. Now I already have a 1 on the right side, but so what are my denominators? I'm going to have to create these denominators by taking the reciprocal of 1 over 9. So I'm going to think about this 9. In reality, 9 is just 1 over 1 over 9. So that's my denominator, 1 over 9. All right. So my center is going to be 2, negative 6. Don't get it mixed up. And my A value is square root 1, 9. My B value is square root 1/4. And so that means C is going to equal the square root of 1/9 plus 1/4, which is square root of 13 over 36, which is root 13 over 6. Okay. And so That means that this is my center, and this is a vertical hyperbola. So that means my vertices are going to be 1/3 added to -6 and 1/3 subtracted from -6. So that should be -17/3 and -19/3. If you don't have a radical, I do not want any plus or minus, because that's not very simplified, in my opinion. In my humble opinion. Although I probably wouldn't take off points. I don't know, depends on my mood. So now the asymptotes is going to be y equals k, which is -6, plus or minus. This is vertical, right? So it's going to be a over b. A over b is 2/3 times x minus h, so x minus 2. And I'm okay with it being left like that. My center is at 2, -6. And I have a vertical hyperbola, right? D. This is a horizontal hyperbola, so I need to draw like that. On to question E, starting to completing the square ones. So, let me first rewrite it by putting the x's in front. So I'll have 9x squared minus 36x, then the y squared in the back, and the 18 to the other side. Factoring out the 9. Here I want to add 4 to complete the square. And factoring out a negative. And then this should be adding plus 9. And then to compensate on the right side, I need to add 36. And then the plus 9 should become a minus 9. So this leaves me with 9x minus 2 squared minus y plus 3 squared equals 9. So my standard form will look like this. Okay, so my center is 2, -3, a equals 1, b equals 3, so c equals root 10. My vertices, this is horizontal, so I'm going to add 1 and subtract 1 from 2. My foci, I will need to add root 10. My asymptotes will be y equals k plus or minus b over a, x minus h. 2, -3, where is that? That's here. My asymptotes are pretty steep, right? I don't know where this actually passes through. Yeah, something like that. Hopefully your sketches are better than mine. Sorry. X squared is already there, so that's a good simplification. Then factoring out a -9 leaves me with minus 4y, and I'll have to add 4 there to complete the square. So on the right-hand side, I'll have to subtract 36. Okay, so that means my center is going to be 0, 2. A is equal to 6, and B equals 2. So that means C equals square root 40. And this is a horizontal hyperbola. So my vertices will be at plus or minus 6, comma 2. Foci at plus or minus 2 root 10, comma 2. Asymptotes at y equals k plus or minus b over a x. Where's my center? It's at 0, 2. My vertices are at 6, 2. My asymptotes are quite shallow, aren't they? All right. F G x squared plus 8x minus y squared plus 21. Sorry, y squared minus y squared plus 2y. I'll bring the 1 to the right side. The right side is 4, so I'll divide everything by 4. So my center is at negative 1, 1. A is equal to 1. B is equal to 2. And C is equal to root 5. This is horizontal once again. So my vertices will be at 0, 1 and negative 2, 1. My foci are at negative 1 plus or minus root 5. My asymptotes are at y equals 1 plus or minus b over a, x minus h. My center is at negative 1, 1. My vertices are at 0, 1 and negative 2, 1. And my asymptotes are fairly steep. Last question. Finally, 16y squared plus 64y minus x squared plus 2x equals negative 64. Is this right? Did I make a mistake? Why does it? Oh, oh, I get it. Um, 16y squared plus 4y, and then I'm going to add 4 here, minus x squared minus 2x. Then I'll add 1 there. Okay, so I'll have minus 64, and then the plus 4 becomes a plus 64, and the plus 1 becomes a minus 1. Uh-oh, bad news, I have a negative number on the right side. What do I do? Well, the good news is that for a hyperbola, you can always divide by a negative number, because I'll just switch the order. So this is totally fine. I just divided both sides by negative 1. For an ellipse, this would not be possible, right? But for a hyperbola, that's totally okay. So the center is at 1, negative 2. A is equal to 1, B is 1/4, and C would be equal to root 17 over 4, like that. Let's see, what was I thinking? Okay, so this is a horizontal hyperbola. So the vertices are going to be right and left. 2, negative 2, and 0, negative 2. And foci would be 1 plus or minus root 17 over 4, a negative 2. And finally, asymptotes, that will be y equals k plus or minus b over a, x minus h. I graph all that. My center's at 1, negative 2. My asymptotes are pretty shallow. My vertices are at 2, -2, and 0, -2. So that should be my graph.